Kubernetes is a very popular container orchestration tool, and there are so many jobs for Kubernetes admins, Kubernetes developers. So in this video, we look at most asked Kubernetes interview question along with answers, providing you with real world examples and practical solutions. So make sure you watch this video till the end. Let's start. Okay, so we are here on my computer screen and I have this document which includes most asked Kubernetes interview questions along with answers. Now this document mostly consists scenario based question, but there are also questions on troubleshooting Kubernetes clusters, how to scale, monitor or secure your Kubernetes cluster, also GitOps, CI/CD and lot many advanced topics. So make sure you watch this video till the end. Along with this document also includes learning resources or projects to help you understand topics more deeper. So if you want me to share this document with you, comment down Kubernetes interview questions and answers, and I will share this document as a PDF on LinkedIn or share this Notion link in the video description. So with that being said, now let's start with the first Kubernetes interview question. So the first few questions in your Kubernetes interview will always be the questions to test your Kubernetes knowledge or to check your past experiences working on Kubernetes. So you will get questions like how Kubernetes work, what is Kubernetes, what does it do, and all similar questions. And to help you answer them all, I have this video which explains what is Kubernetes and how it works. It is around 28 minutes, so it will help you clear all your Kubernetes concepts and also help you answer these kind of questions. So I would recommend you checking out this video. But to answer this particular question, what is Kubernetes and what does it do? Kubernetes, as we all know, is an open source container orchestration or container management tool that automates the deployment, scaling and management of containers. Along with this, you will also have a question on Kubernetes architecture. So make sure you go through the Kubernetes architecture properly, understand what is inside master node, what is inside worker node, how they work together. So I also have this video which explains Kubernetes architecture in 7 minutes. I have drawn out the architecture so it is very easy to understand. And to answer this question, the main components of Kubernetes architecture are the master node and the worker node. Master node is something that will handle everything inside the cluster, and it consists of Kube API server, HCD, scheduler and controller manager. Whereas worker node is something which is running your application in the cluster. So it consists of kubelet, kubeproxy, container runtime and the pods on which your containers are running. So these are two different questions that you will obviously get. Now that we have covered this, let's move on to the scenario based questions. So we have first scenario based question which says you have an application deployed on Kubernetes that is experiencing increased traffic. How would you scale the application to handle the increased load? So you have an application running on Kubernetes which is getting a lot of traffic and you want to scale up. So you can scale the pods either horizontally or scale it vertically. To scale the application, I would follow these steps. First, identify the bottleneck. So I will check the cluster to analyze resource utilization, including CPU, memory, network, to determine the limiting factor. Once I know this, and if the bottleneck is CPU or memory, I would scale the application horizontally by increasing the number of replicas using horizontal pod autoscaler. But if the bottleneck is resource specific, I would vertically scale the application by upgrading the resources allocated to each pod. So this is how you can scale your application either horizontally or vertically. Once you scale it, you can then monitor and validate to check the application performance if everything is working fine after scaling. Other than this, in Kubernetes, you can also scale your nodes, and that can be done using autoscaler or also tools like Kida. Now that you have understood this, let's move on to the next question, which is a troubleshooting question. So while troubleshooting a network issue in the cluster, you noticed kubeproxy in the logs. What is the role of kubeproxy? So this is, as I said, a Kubernetes architecture kind of question asking you what is kubeproxy. So kubeproxy is a component that runs on every node, and it is a network component that handles TCP and UDP packets forwarding between the backend network services. It is very important for reliable communication between pods and the services within the cluster. It does that by routing traffic to the right destination. And if you want to go deep, understand how kubeproxy handles TCP UDP traffic using IP tables, you can check out the official documentation where it explains what is kubeproxy and how it actually works. Moving on, the next scenario based question is your team is planning a high availability Kubernetes cluster. Describe the process and considerations for designing a highly available Kubernetes cluster. So this is a scenario based question to create a high availability Kubernetes cluster, and we do this in production for our critical application. So whenever we create a highly available cluster, we need to deploy the nodes and the pods in 3 different or many different AZs. So to create a highly available cluster, we first do the multi-master setup where we deploy multiple master nodes across 3 different AZs to ensure redundancy and fault tolerance. This is the diagram here. So we have 3 different master nodes, which is known as multi-master setup. If we have 3 different master nodes, we also need to distribute the HCD, which is the data storage that stores all the information about the cluster. So we distribute HCD members across the AZs in the similar fashion as the master node. This ensures data redundancy and resilience against zone failures. Now if we have 3 different master nodes to distribute the traffic, we also need a load balancer. So we configure a TCP load balancer such as AWS network load balancer to evenly distribute API requests among the API server. This setup eliminates the risk of single API server becoming a bottleneck or a point of failure. Along with this, we also enable node auto repair, which is a feature by Kubernetes engine to make sure that it automatically detects and replaces the unhealthy nodes. So this is how you can set up a highly available Kubernetes cluster, something you should definitely know. And you can also check out this blog which explains how to create a Kubernetes highly available cluster. Now moving on, the next question is again a scenario based question. In your Kubernetes environment, a master or a worker node suddenly fails. What happens when the master or worker node fails? So this is a question that I got recently in my Kubernetes interviews. So make sure you understand this properly. What will happen if one of the nodes fail? If the master node fails, what happens? If worker node fails, what happens? So we all know master node is something that is used to handle everything inside the cluster. And if the master node fails, the cluster continues to operate normally, but the pod management is lost. So if the master node fails, there is no management for the pods. There are no new pods going to be created. Whereas if the worker node fails, worker node is something that is running your application. So if the worker node fails, obviously the application running on it will also be failed. So you will get DNS failures on the worker node, but the master node is going to run properly. Kubernetes, when finds out that the worker node is failing, it will mark that node as not ready so that the new pods are not going to be created on that. And the scheduler is going to remove that pods which are on the failed worker node, and it will launch it somewhere else on the other nodes. So this is what happens when the worker or the master node fails. Now that we know this, let's move on to the next question, which is how does ingress help in Kubernetes? So ingress is a Kubernetes object that is used to expose the services to the external world. So ingress is a resource that defines rule to expose services to external traffic, and it also provides you all these features. It exposes the services to the internet using a single IP address or a domain name. It routes the traffic to your services based on host name or host path. It also provides features like load balancing, SSL termination, name-based virtual hosting, and it simplifies the management and configuration of your services. So this is what ingress does. Moving on, the next question is, you are selecting a service to expose your application hosted on Kubernetes. List the different types of services in Kubernetes. So service is a Kubernetes object that is used to expose your application running on the nodes to the outside world. And there are different types of services like cluster IP, node port, load balancer, and external name. So cluster IP here is the default Kubernetes service which exposes the application on cluster's internal IP address, which means the application is only accessible inside the cluster, within the cluster. Next is node port. In this service type, you expose your application on the node's IP address some particular port. So worker node IP address, some port. It exposes a service on a static port on each node in the cluster, making it accessible from the outside cluster. And we also have projects which are using node port. The project microservices Python application to convert video to audio is using node port as a service. Next service type is load balancer. In this, you provision an external load balancer in the cloud, directing traffic to the Kubernetes service. So when you use load balancer as a service type, you will be creating a load balancer in the cloud that will be used to expose our application. Lastly, we have external name. In this, you map the service to an external DNS name, enabling referencing of external services by the name from within the cluster. So these are different service type in Kubernetes. Once you understand this or you answer this, the follow-up question could be, what do you know about headless service? So this is again another type of service where the type is cluster IP, but there is no IP address attached to the service. So headless service in Kubernetes is a type of service that doesn't allocate a cluster IP. So here the spec cluster IP is set to none and the spec type is cluster IP. To understand this more properly, I can show you the manifest for this particular headless service. So this is what the manifest looks like. You have the service and the type is cluster IP, but it is set to none, which means the service is not going to have any IP. And if you want to access anything, you can directly access the pods behind the services. We have also used this type of service in this particular project. So if you want to see how it works, you can go through and do this project as well. Now this type of services are used for databases, as we have used inside our project for MongoDB databases. And the next question we have is, your manager has instructed you to run several scripts before starting the main application in your Kubernetes pod and suggested using init containers. What are init containers? So init containers in Kubernetes are something that will run before your main application runs. So you have two containers inside a pod. One is init container, another is application container. This init container will run before the main application container is running. And we use this for different use cases like running a script, setting up network configuration, or downloading configuration file, or anything that needs to be done before the application starts. So init container is a type of container in Kubernetes that runs before the main application container in the pod runs. And the purpose of init container is to perform initialization tasks or setup procedures that are not present inside the application container images. So this is how init containers are used. Apart from this, there are also other types of containers like ambassador or sidecar containers. I've explained sidecar containers in one of the shorts recently, so you can also check that out. Moving on, the next question is, a critical application running on one of the node is not working properly. How do you monitor applications in Kubernetes? So this question is on how you monitor applications. For monitoring application, you can use tools like Prometheus, Grafana, Splunk, and there are also other monitoring tools for Kubernetes which you can use. But here I've mentioned some few points that you can explain in your interviews. So to collect container metrics, you can use tools like CAdvisor or container runtimes. You can also use commands like kubectl top or kubectl stat. Next, for getting cluster level metrics, you can use Kubernetes monitoring tools like kubestate metrics, metric server. To get the logs, you can use EFK or Loki or other tools. You can also use readiness and liveness probe for health check to monitor the application. You can also set up alerting to get alerts on Slack, Teams, mails, etc. using Prometheus Alert Manager. And optionally, you can also use third-party tools like all the different monitoring tools that we have. So this is how you can monitor your application running on Kubernetes. Next, we have another scenario-based question on GitOps. So your manager read an article on GitOps and want you to do a POC on it. What is GitOps and how do you implement it? So we all know GitOps is something that is used to automate your deployments on Kubernetes. So how it works is you push your manifest files on a repository like GitHub, and once you push this, anytime you make a change, the GitOps tool will get that and update it in your Kubernetes cluster. So I've mentioned here, for Kubernetes, GitOps is a practice where all the configuration, include manifest file or Helm charts, are stored in Git repository. Changes to this repository will trigger a configuration using deployment pipelines, ensuring that the cluster desired state matches the code in the repository. And this approach streamlines management, promotes collaboration, and provides a clear audit trail. You can do this using tools like Argo CD, Flux CD. I have this video which explains GitOps very properly with a project to deploy Tetris game on Kubernetes using Argo CD. So I recommend you checking it out if you have no clue about GitOps. Next, the company is very concerned about securing cluster. List some security measures that you can take while using Kubernetes. So this question is on securing Kubernetes cluster, very important thing that a DevOps engineer should know. So how can you secure your Kubernetes clusters? You can secure using all these different ways. First is RBAC, so you restrict users' access based on their roles. Then you can use network policies to determine or to handle the traffic inside the pod or even to external communication as well. Container security, ensure secure runtimes and image scanning. Secrets management, you should always secure your secrets either using Kubernetes secrets or using other tools like HashiCorp Vault, AWS Secrets Manager. Audit logging, always track activities for security monitoring. Update and patching, make sure your clusters are up to date and maintain the component and node's current version as well. You can also use third-party security tools, which are a lot of them right now in the CNCF landscape. So I don't want to name all of them, but this is how you can secure your Kubernetes clusters. Now, the follow-up question could be, explain what is Kubernetes RBAC. So RBAC stands for Role-Based Access Control, and it is a Kubernetes way to restrict access to different resources like deployments, pods, manifest. In RBAC, you can define what are the different roles attached to a particular user. So let's say this user can only create deployments, but it cannot access nodes or it cannot access pods. So this is what you can do using RBAC, you define roles with specific permissions like create, delete, and bind them to users or groups using role bindings. RBAC ensures users and application have access only to necessary resources, following the principle of least privilege and enhancing security. So this is what RBAC is, and I've also explained or ran the commands to create roles and role binding in the CK exam question. So if you want to know how to create roles and attach them, you can check that out. Moving on, the next question is, how do you perform maintenance on the Kubernetes nodes? So to perform the maintenance, you first need to make sure that the application running on that node is removed. So you first make the node unschedulable, which means no new pod should be running on it, and you can do that using kubectl cordon command. Once you do this, next step is to remove all the existing pod using the kubectl drain command. Then perform your maintenance. Optionally, you can reboot the node. Once everything is done properly, you can then uncordon it to make sure that the pods are deployed on the nodes again, and you can also verify the status using kubectl get nodes or kubectl describe command. Okay, moving on, the next question is explain daemon sets. So daemon sets in Kubernetes are used to deploy pods on every node inside the cluster. So daemon set ensures that the specific pod runs on every node in the cluster, and they are used for system level tasks like logging or monitoring that needs to be deployed on each node. So when you create a daemon set manifest like this and you run it, this pod, which is a fluent D image, is going to be running on every node, and this is what daemon set does. It will make sure that the pod is running on every node. Each matching node has exactly one instance of the pod created by daemon set running on it, and you can learn more about daemon set here from the official documentation. You can also see daemon set ensures that all nodes run a copy of the pod that is defined inside this daemon set here. Moving on, the next question is, a junior engineer working with database on Kubernetes is confused and asks you to differentiate between config maps and secret. Again, a very important question. People are confused about config maps and secrets. What does config maps hold? What does secret hold? So config maps are generally used to save the application configuration, whereas secrets are used to store credentials like database passwords, usernames, API keys, and etc. So config map ideally stores the application configuration in the plain text, whereas secrets store sensitive data like passwords in an encrypted format. Both config map and secrets can be used as a volume and mounted inside the pod through a pod definition file, which is true. So here's an example of how you can create a config map. So we are creating a config map that is holding a value environment equals to dev. Here we have a secret that is first encrypted and then stored inside the secret. This is how you can create it, and you can then use both of them inside the pod manifest as a volume. Moving on, the next question is, what is the purpose of operators? Again, a very important topic that a DevOps engineer should know. You will get this question in advanced Kubernetes interviews. So the purpose of operators, we use operators to package complex application that needs to be run on Kubernetes cluster. So a Kubernetes operator is a method of packaging, deploying, and managing Kubernetes application. Operators uses the Kubernetes API to automate tasks such as deployment, scaling, implementing custom controllers, enabling self-healing systems, supporting declarative management practices. So in short, if you want to deploy something on Kubernetes, you can use operators which can help you deploy complex applications. You can find all the different operators on Operator Hub. So if I show you, this is operatorhub.io, where you can use operators to deploy them on your clusters. So if you want to deploy Argo CD, you can directly do it. You can also use Prometheus. If you want to monitor your applications, you can use Prometheus operator, which is given by Red Hat here. So for example, the Prometheus operators automate the deployment and management of Prometheus monitoring instances on Kubernetes, handling tasks such as configuration, scaling, and self-healing. So you can customize them as well. You can customize the custom role resource definitions and then deploy them on your Kubernetes clusters. To learn more about it, you can go through this CNCF blog, which explains what are operators and how to use them, along with some examples as well. Moving on, the next question is, how can you run a pod on a specific node? So you have a pod that you want to run on a specific node. How can you do that? You can do that using node affinity or node selectors, and you can also do that using node name. So how this works is, you first label the node. So you can label the node using label. So I'm labeling a node which is node 01. The label is node location equal to Germany. Once you do that, you can then set the affinity rules by saying that the pod should be running on the node which has the label as Germany. Whereas you can also use node name, where you can specify that the node name equals to node 01 and the pod will run on that particular node. So this is how you can run a pod on a specific node. Now here is also an example. So node affinity is set as node name equals to app worker node, and this is the node which has the label app worker node. This has app web node. So the pod will be running on this particular node. This is using affinity rules. Moving on, the next question is, suppose a pod exceeds its memory limit, what signal will be sent to the process? So if you work on Kubernetes, you will obviously see an error something like OOM killed or out of memory killed. You get this, and if you get this, the application is stopped. So when a pod exceeds its memory limit, the kernel's out of memory killers may send the SIG kill signal to process and terminates it immediately. So in Kubernetes, when a container in the pod is terminated to memory limits, in the container runtime, which is Docker or container D, may send the signal to main process with the container leading to immediate termination. So this is what you get whenever the memory is out of the limit that is mentioned inside the pod manifest. The next question is, you need to ensure that the specific pod remains operational at all times. How to make sure that the pod is always running? To do this, you can use probes. So here is an example of how you can use liveness probes to make sure that the application is running all times. So this is one of the most frequently asked Kubernetes interview questions, and the answer here is, we can use probes. A liveness probe within the pod is ideal in this scenario. Liveness probe always checks if an application in the pod is running. If this check fails, the container gets restarted, and this is ideal in many scenarios where the container is running but somehow the application inside the container crashes. So you can make sure that the application is running all the time using liveness probes. Now let's move on. The next question is, what will you do to upgrade a Kubernetes cluster? This is a very important question, and you should know how to upgrade a Kubernetes cluster, because Kubernetes releases new version every 4 months, and this is something a DevOps engineer does in their day-to-day activities. So you can upgrade a Kubernetes cluster using the help of the official documentation. If you search for upgrade Kubernetes cluster, you will find the official documentation which has the steps on how you can upgrade it. So if you check this, it will show you that you need to first start with upgrading the master node and then go with upgrading the worker nodes, and that's what mentioned in this answer is here as well. So to update the Kubernetes cluster, one needs to update the components of the cluster, and the specific instructions to upgrade the same depends on the specific setup and configuration used, that you can check in this here. So documentation has different pages for you to upgrade from one version to another, and the steps mentioned here is, first, find the desired target version and the upgrade plan, save all the data, always take backup. Now upgrade the control plane, which is the master node components. Also upgrade the worker node components one by one through a rolling upgrade process, which is the default process. And finally, when the upgrade is done, verify whether the cluster and the components are working properly or not. So this is the step-by-step on how you need to upgrade a Kubernetes cluster. Again, if you want to see in practical how to upgrade a cluster, I have shown that in the CK questions video. You can check how to upgrade a Kubernetes cluster. Moving on, the next question is, why should we use custom namespaces? So by default, whenever you create a Kubernetes cluster, you get some namespaces, and you can also launch your applications in that. But why should we use our own custom namespaces? We should use it to properly distribute our application according to their actual use case. So by creating custom namespaces, you can logically group your resources based on your needs, such as separating production and development environments or separating applications by team and department. This makes it easier to manage and maintain your resources within the cluster, and also provides better security and resource isolation. In this diagram here, you can see we have some resources deployed in default namespace, some in dev namespace, some in QA namespace. Using this, we understand that this belongs to dev environment. This belongs to QA environment. So using custom namespace, you can logically group them and also separate them. Moving on, the next question is, can you schedule the pod to a node if the node is tainted? So what do you mean by a tainted node, and how can you schedule the pod on it? So if you look here in the diagram, this node is tainted, which means no pod is going to be deployed on this particular node. But the question is asking, how can you schedule a pod to the node if the node is tainted? So you can do that by using tolerations. So if you want a pod to be deployed here, it should have the toleration for this particular taint. So you can see if the node is tainted, pods will not be scheduled on it by default. but you can use tolerations in the pod spec to allow specific pods to be scheduled on that tainted node. Tolerations are used to specify the pod. Tolerations are used to specify that the pod can tolerate or ignore a certain taint, allowing it to be scheduled on that tainted node. So how it works, you can taint a node using the command kubectl taint with this particular taint information. Once you add a taint, and if you want to add a pod on that, you can add toleration like this. If the pod has this toleration, it can be deployed on the node which is tainted. So this can be useful in scenarios where you want to reserve certain nodes for specific types of workloads, or to mark nodes as unsuitable for certain workloads. So this is how you can deploy a pod on a tainted node. So yeah, that is all we have. So I hope all these questions that we have discussed in this particular video are helpful, and this will help you in your Kubernetes interviews. If you have any questions, any doubts, do let me know. And if you want me to share this document with you, let me know in the comment section. I hope this video was informative. Thank you and have a good day. Bye.